Good morning, students. अनिकेत, आवाज येतोय का?
Yes, sir.
ओके. सुरू करू आपण. 8 वाजलेत. तर सुरू करायच्या अगोदर मला काही गोष्टी सांगायच्या आहेत. मागच्या आठवड्यामध्ये 2 लेक्चर आपली बुडाली काही कारणामुळे. ते आपण नंतर घेऊया, कंडक्ट करू. आतापर्यंत जो सिलेबस झालेला आहे त्याचा थोडासा मला आढावा घ्यायचा आहे, कारण आपण प्रत्यक्ष भेटू शकत नाहीये. हे व्हर्च्युअल किती दिवस चालणार आहे माहित नाहीये. हे बघा, ऑर्गॅनिकचे आपण सगळे चॅप्टर संपवलेले आहेत बघा. म्हणजे चॅप्टर नंबर 10, चॅप्टर नंबर 11. थोडस 2 मिनिटं मुलं जॉईन होतोपर्यंत सांगतो आणि नंतर मग आपण सुरू करू. स्क्रीनच शेअर करतो मी. रिड्यूस सिलेबसची स्क्रीन आहे, बघून घ्या. जर कोणाकडे रिड्यूस सिलेबस नसेल तर बघून घ्या. ही रिड्यूस सिलेबसची स्क्रीन आहे. आता बघा, सॉलिड स्टेट आपण मुद्दाम मागे ठेवलाय, आज सुरू करणार आहे. मला सांगायचं ऑर्गॅनिक केमिस्ट्री आपण अगोदर संपवलेलं आहे सगळं. म्हणजे चॅप्टर नंबर 10 इथून बघा. दिसते ना स्क्रीन? दिसते का सगळ्यांना?
Yes, sir.
हा, इकडे बघा. हे ऑर्गॅनिकचे चॅप्टर आपण सगळे संपवलेले आहेत आणि हा रिड्यूस सिलेबस आहे. जर कोणाकडे रिड्यूस सिलेबस नसेल तर बघा, सँडमिन रिएक्शन ही चॅप्टर नंबर 10 मध्ये विचारणार नाहीये, ती विचारणार आहे चॅप्टर नंबर 13 मध्ये. त्याच्यानंतर कुठलीच लॅबोरेटरी टेस्ट आपण ठेवलेली नाहीये, सगळी काढून टाकली. म्हणजे लॅबोरेटरी टेस्ट फॉर अमाइन्स असतील, लॅबोरेटरी टेस्ट फॉर अल्डिहाइड्स असतील, लॅबोरेटरी टेस्ट फॉर केटोन्स असतील, किंवा अल्कोहोल्सचे असतील, फिनॉल्सचे असतील, इथरचे असतील, कुठलीही लॅबोरेटरी टेस्ट तुम्हाला परीक्षेला येणार नाहीये. ते सगळे आपण नॉन इव्हॅल्युएटिव्ह करून टाकलेले आहेत. त्याच्यानंतर महत्वाचा पार्ट म्हणजे एन्व्हायरमेंटल इफेक्ट्स आणि युजेस हा शेवटी दिलेला आहे हॅलोजन डेरिव्हेटिव्ह, तो परीक्षेला विचारणार नाहीये. तर 10वा चॅप्टर हा आपण संपवलेला होता. त्याच्यानंतर 11वा चॅप्टर अल्कोहोल, फिनोल्स, इथर संपवलेला आहे आपण. याची प्रॅक्टिस करा, कारण हे शेवटी परीक्षेच्या वेळेस तुम्हाला लक्षात राहणार नाही. सारख्या याला रिव्हिजन पाहिजे. फॉर एक्झाम्पल मेथड्स ऑफ प्रिपरेशन, त्याच्यानंतर IUPSC याचे चार्ट बनवा आणि त्याची रिव्हिजन करा. तर संपवलेले चॅप्टर मला सांगायचंय. पहिल्यांदा आपण 10वा, 11, त्याच्यानंतर 12, 13, 14वा राहिलाय, 15वा संपवला, 16वा संपवला. हे जे चॅप्टर आहेत 15, 16, 14, 15, 16, these are the chapters for applied chemistry. So the weightage is very, though the chapters are very large, the weightage is very small. The weightage is only 4 marks, 3 and 4. 3 marks without option and 4 marks with option. So these 3 chapters, आता जर तुम्ही अभ्यासाला सुरुवात केली असेल किंवा करणार असेल तर we have to start from organic chemistry first. Means chapter number 10 we have to start. After this chapter number 10 we have to start for chapter number 11, because some concepts are again repeated. Halogenation, hydrogenation, then elimination reactions. If you understand in halogen derivative, then you can do well in the chapter number 11. Then after completion chapter number 11, go to the chapter number 12, aldehyde ketone. This is the biggest chapter in organic chemistry. It is having 8 marks weightage. Though the chapter is biggest, but it is very easy. And also I have given the notes in simple manner also. Then come to the amines. This is very small chapter. Nitro part is eliminated. So for this new syllabus, only the amines are introduced for the syllabus. Nitro, it is reduced. In old syllabus, nitro is also there. Compounds containing nitrogen in that chapter. Nitro part is also included and amine part was also there. But in the new syllabus, only amine part is it is kept for the examination, and nitro part it is permanently deleted. Then introduction to the polymer chemistry. This is also the very interesting chapter. So we completed chapter number 10, 11. Yes. 10 is completed, 11 is completed, 12, 13, 14 is not completed, 15 is completed, and 16 is completed. So organic chemistry and applied chemistry part is completed. Then we started the chapter coordination compounds. This is a newly introduced chapter in the syllabus. This chapter is also completed. In this chapter, the main part is eliminated, that is crystal field theory. Crystal field splitting is eliminated. This will be not for the examination. Only for the board examination it is eliminated. But for the competitive examination, it is not eliminated. So we have to study for competitive examinations. So the chapter number 9 is completed. Then chapter number 2. I am coming to the chapter number 2, solutions, physical chemistry. This chapter is completed. Then chapter number 3 is completed. Then chapter number 7 is completed, and chapter number 8 is completed. Now the remaining chapters I will tell you. Chapter number 1 is remaining. Then chapter number 4 is remaining. Chapter 5 is remaining. Then chapter number 6 is remaining, and chapter number that biomolecules, chapter number 14 is remaining. So in this week, we have to complete this solid state. In the next week, we have to complete the biomolecules, so we can complete the syllabus before Diwali vacation. Now today, we are going to start. This is a again interesting chapter which is included in physical chemistry, solid state. The weightage is reduced this year. Last year weightage was 4 with 6 marks, but 1 mark is reduced. It is having the weightage marks 3 with option 5 marks. So those students who don't have the unit-wise distribution marks, so for these students, I have given again the unit-wise distribution of marks of each chapter, solid state and solutions. All this is yesterday at 11:15. I have also sent the mails to you. In that mail, you will find this unit-wise weightage of all this chapter. Now we will start. So what is meant by solid state? We already heard this word because there are generally 3 states of matter. These are the very common states of matter, and the 4th one is plasma, but its chemistry is not very much known, so we didn't consider the plasma as a main states of matter. Main states of common states of matters, these are the solid, liquid, and gases. In this chapter only we will consider about the solid state. So the solids having the property, they having the definite shape and also the definite volume due to the strong interparticle forces. Interparticle forces in case of solids are very strong. In case of liquids, these are weak, and in case of gases, again these are very, very weak. So these are the general properties of solids. The shape and volume of the solids can be slightly changed with the change in temperature and the change in pressure. And the last part is the smallest constituent particles, means the smallest constituent particles by which that solid material is made. These are atoms or ions or molecules. So this is the general introduction. In the chapter we will discuss the different types of solids, then close packing, Then next one is electrical properties of solids, semiconductors, metals, insulators, and magnetic properties, paramagnetic, diamagnetic, and ferromagnetic properties. So first part is classification of solids. Mainly the solids are classified into two main classes: crystalline solids and amorphous solids. In your school days, you know about what is meant by crystalline solids and amorphous solids. So again, these crystalline solids are classified in the four types: molecular solids, depending upon the bonding. So molecular solids, again, these are also actually classified in three parts: polar, non-polar, and hydrogen bonded. But this classification, it is included in the molecular solid. So crystalline solids again classified into four classes: molecular, ionic solids, ionic bond is there, then metallic solids, metallic bond is there, and covalent bonded solids, covalent bond is there. So in the reduced syllabus, this crystalline and amorphous part is reduced this year. So I will not discuss about the crystalline solids, what is meant by crystalline solids and what is meant by amorphous solids, because this part is non-evaluative part this year. Those who want to read, they can read. It is very simple and it is very easy. Now, what is meant by crystalline solids? They having the definite geometry, they having definite shape, they having the sharp melting points. Then they also having the anisotropic properties. I will discuss this anisotropic and isotropic, but this amorphous solids and crystalline solids and the difference between amorphous and crystalline solids, this part is non-evaluative. So no any question will be asked on this part. Difference between crystalline solids, amorphous solids, this is a non-evaluative part. Directly I am coming to the anisotropy and isotropy. These are the some properties of solids I will explain. Actually, this is also non-evaluative. Anisotropy and isotropy is also non-evaluative. But within 2 minutes, I will explain. No any question will be asked on this anisotropy and isotropy. So, okay. What is mean by anisotropy? I will explain. See this diagram carefully. In this diagram, this is a diagram of one crystal solid, one biggest crystal solid. This is made up of with particles. We can see this blue color particles and this is a pink color particles. We can see this is arrangement of particles in the crystal. So if the direction changes, see this direction AB, we can find all the particles are same. In the direction CD, we can
not
find
visible, sir.
Not visible.
No, sir.
Yes, visible, na?
No.
Okay. See those students who
Slide change नाही झाली.
एक मिनिट आता झाली आहे का बघितलं
नाही सर
अनिसोट्रॉपी आयसोट्रॉपी दिसतंय का तुम्हाला
ते डिटेल सिलेबसच दिसतोय
ओके ओके सॉरी 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 आता दिसतंय का
येस सर
येस
का म्हणजे बघा की तुम्हाला हा पार्ट्स परीक्षेला विचारणार नाहीये परत एकदा मी सांगतो हे सगळं काही दिसलं नाही का तुम्हाला ठीक आहे हे सगळं मी रात्री तुम्हाला पीपीटी मध्ये पीडीएफ करून पाठवलेलं आहे हा युनिट वाईज डिस्ट्रीब्युशन आहे त्याच्यानंतर हे क्लासिफिकेशन आहे बघून घ्या क्लासिफिकेशन ऑफ सॉलिड्स solids are mainly classified in two parts, crystalline and amorphous. So crystalline solids again classified in four main types depending upon the bonding: molecular solids, ionic solids, metallic solids, and covalent solids. This is depending upon the bonding. Actually, again, there are three types of molecular solids. These are polar, non-polar, and hydrogen bonded. But its classification is not given. Directly, it is merged in this molecular solids. So, for the board examination this year, this crystalline and amorphous, this part is non-evaluative. So, these types of solids, we can see crystalline solids. This part is non-evaluative. Also, this amorphous solids, this is also non-evaluative. We will start from this some properties of solids. Actually, this is also non-evaluative, anisotropy and isotropy, but it requires only 2 minutes to complete. So I will complete what is meant by anisotropy and what is meant by isotropy. For understanding anisotropy and isotropy, we have to see this diagram carefully. In this diagram, we can see one crystal. The particles of the crystals are arranged blue colored. Some particles are blue colored and some particles are, you can see here, red color particles. So in the direction AB, all the particles are same. In the direction CD also, all the particles are same, but the particles are changed. But if you can see this EF direction, there are different particles: red particle, blue, red, blue, red, blue, red, blue. So when the direction changes, physical properties also changes. This property is called as anisotropy. Remember. So anisotropy is nothing but it is found in case of crystalline solids or crystalline substances, except those having the cubic structure. Cubic structure do not shows this property. This is exceptional. So all the crystalline solids except cubic structure, they having the properties such as refractive index, thermal and electrical conductivity. These properties are different in different direction. This is called as anisotropy. And what is meant by isotropy? Opposite to this anisotropy, it is called as isotropy. Above mentioned properties, these mentioned properties, refractive index, thermal and electrical conductivity, these are same in this direction also, in this direction also. This is called as isotropy. Means these properties do not changes when the direction is changed. It is called as isotropic. So isotropy, it is shown by the amorphous substances or amorphous solids, and anisotropy, it is shown by the crystalline solids or crystalline substances, except those who have the cubic structure. So for the competitive exam, for the JEE exam, for the NEET exam, for the CET exam, this concept is very important: anisotropy and isotropy. And then second, there are also the isomorphism and polymorphism. These are the some also properties of solids. First, I will discuss what is meant by isomorphism. So isomorphism means existence of two or more substances having the same crystal structure. Means two or more substances are there and they having the same crystal structure. It is called as isomorphism. And what is meant by polymorphism? Existence of single substance in two or more forms. It is called as polymorphous substances or polymorphism. Means two substances having the same crystal structure, it is called as isomorphism, and one substance having the two different forms, it is called as polymorphism. See the difference between iso and poly, because board at the board exam, student always makes confusion between these iso and polymorphism. So first I will discuss this isomorphism. As the definition is explained: existence of two or more substances having the same crystal structure. There are one example is given: NAF and MgO. These are the two different substances, but they having the crystal structure is same. Also, they having the same atomic ratio. So this NAF and MgO having the same atomic ratio 1s to 1. Also, there is another example is given. There are the two substances NaNO3 and CaCO3. These are also the two different structures, but having the Sorry, these are the two different substances having the same crystal structure. So we for the examination purpose, you can write this example or you can write this example. They having the same atomic ratio is 1:1 for this, and atomic ratio is 1:3 for these NaNO3 and CO3. Then I am coming to the polymorphism. As the definition it is explained. Existence of single substance means substance is single, but it is having the two or more forms. Better example you can remember allotropes. So carbon, it is a single substance, but it is also having the two or more forms. It is also called as allotropy. So for the board examination, don't make confusion. Polymorphism is also the allotropy. So we can remember the isomorphism. Polymorphism means allotropy, and you know about the allotropy means the substance is single, but it is having two or more forms. So we can correlate this polymorphism and allotropy. The example is given: calcium carbonate. It is a single substance which exists in two polymorphous forms. One is calcite and second one is aragonite. Polymorphism occurring in elements, it is also called as allotropy. You are very familiar with this word allotropy. Physical forms are only different, but the chemical properties are same. The allotropes of carbon, these are very famous. Carbon having the three allotropic forms, or polymorphic, it is also called as polymorphic forms, mainly the diamond. It is a very giant molecule. You know about this diamond. Then graphite, it is soft because it is a layered structure, two layers having the van der Waals forces. In 11th standard, this is explained: diamond, graphite, and fullerene. So it is not explained here. So for the examination purpose, they can ask the short note on isomorphism, they can ask the short note on polymorphism, or one mark definition can be asked, or examples can be asked. This part is non-evaluative part. No any question will be asked. Difference between crystalline and amorphous solids. Also, this part is not given in your textbook, but additional notes I have given for the students' purpose. This difference you cannot find in your textbook, but the question is there. Explain the difference between crystalline solids or amorphous solids, but only for this year. This question will be not asked because it is non-evaluative part. Now the classification of crystalline solids, we already saw this chart, this classification chart. Crystalline, we will see this classification: molecular, ionic, metallic, and covalent. For understanding this classification, I have also prepared one at a glance chart. So first I will explain one by one, and then we have to check this chart. At a glance, we can remember this ionic crystals, covalent and network solid, and this molecular crystals and metallic crystals. But I have prepared the individual notes of this classification. Mainly the molecular solids are classified into the four categories. First one is ionic solids, or it is also called as ionic crystals, covalent or network solids, or covalent solids, molecular solids, and metallic solids. So first we will discuss the ionic crystals or ionic solids. Screen दिसती है क्या? Anyone?
Yes, sir.
So these ionic crystals, these are made up with ions. Means the constituent particles are ions. Ions, you know, there are two types of ions: positively charged and negatively charged. Positively charged, these are called as cations, and negatively charged are called as anions. So the smallest particle of these ionic crystals are charged ions. Remember, it is called as constituent particles. Means by this particle, ionic solid is made. So the constituent particles, these are charged ions, positively and negatively charged. Then These particles of ionic crystals, particles means these ions. These ions of ionic crystals are held by electrostatic force of attraction. So this electrostatic force of attraction is there between positively charged cations and negatively charged anions. Then third point, ionic crystals are hard and brittle. They also having the high melting point. You know about this hard and brittle, so I will not explain what is meant by hard and brittle. Then these are non-conductors of electricity in solid state. Remember this sentence carefully. Ionic solids do not conduct electricity in solid state, but they are the good conductor of electricity when these are dissolved or when they melted in, they dissolved in water or they melted, because the ions will be created and the electrons are required for the conduction of electricity. So in aqueous state they can conduct the electricity, but in solid state they do not conduct electricity. Examples are given, some examples of ionic solids. NaCl, you are very familiar with this NaCl. Then these are salts. K2SO4, then CaF2, and this KCl. These are made up with positively charged cations and negatively charged anions. So for the examination purpose, they can write a short note on ionic solids or ionic crystals. So we have to write all these points for 2 marks. Then I'm coming to the covalent or network solids. Some properties or characteristics are given. The constituent particles in case of covalent solids are atoms. See, the constituent particles, these are atoms. In case of ionic solids, the constituent particles are charged ions. But in case of these covalent solids, these are atoms. So these atoms of these crystals are linked together with a continuous system, and the giant molecule it is formed. For example, diamond. So diamond, it is prepared with the atoms of carbon atoms which are bonded together with covalent bond. It is a very giant molecule. The results in a very rigid three-dimensional network that is forms. A very giant molecule is formed, and the entire crystal is a single molecule. So in other words, I will explain. As the constituent particles in case of this covalent solids are atoms. So atoms, one atom, second atom, third atom, many atoms join together, and a giant molecule is formed, and this giant molecule it is bonded with covalent bonds. For example, diamond. If you remember the structure of diamond it is prepared with, in which all the carbon atoms are bonded together with covalent bond. A very big molecule it is formed. This is an example of covalent or solid or covalent or network crystal. So as a result of rigid and strongly bonded structure, covalent network crystals are very, very hard. Diamond is very hard, but the graphite is not very hard, because the graphite is layered structure. Graphite is having the layered structure, and these layers are bound together with van der Waals forces. But the diamond is very, very hard. It is the hardest substance on the earth. They having the high melting and boiling points. Then the electrons are localized in covalent bonds, and these are not mobile. There is no any mobile electron in case of diamond. So as a result, covalent solids are poor conductors of heat and electricity. As there is no any free electron, so they will not conduct electricity. For example, it is given diamond quartz. Quartz is also called as SiO2, silicon oxide. Then I am coming to the molecular crystals, molecular solids or molecular crystals. Again, there are 3 parts: polar, non-polar, and hydrogen bonded. So in case of these molecular crystals, The constituent particles of these molecular solids are molecules. Each time you have to concentrate on the constituent particles. Once again, I am repeating, in case of ionic solids, the constituent particles are charge ions. In case of covalent or network crystals, the constituent particles are atoms, and in case of these molecular crystal, the constituent particles are molecules. These molecules are unbonded single atoms, or these are the molecules of the same substance. Then second one, the bonds within the molecules are covalent. So the molecules, these are also bonded with covalent bond. But this covalent bond, there are again the three types of covalent bond, depend upon the interaction. First one is weak dipole-dipole interaction. Polar molecules having this dipole-dipole interaction. You know what is mean by polar molecule? Separated with permanent dipole. For example, this HCl, H plus and Cl minus, it is polar molecule. So if the polar molecules are there, the interaction is weak dipole-dipole interaction, which possesses the permanent dipole moment. Then second type is very weak dispersion or London forces. This is found in non-polar molecules. For example, it is given CH4, solid CH4 or solid H2. Then third one is intermolecular hydrogen bonded solids. So hydrogen bonded, you know about the hydrogen bond. When the hydrogen bond is formed, hydrogen bond always formed with hydrogen, and the most electronegative element is there. There are three electronegative elements. One is oxygen, and then fluorine and nitrogen. So the three examples are given here. This is a hydrogen bond between oxygen and water in case of ice, in case of NH3, and in case of HF. So these are the hydrogen bonded molecules. Because of weak intermolecular attractive forces, molecular solids are generally soft substances. They having the low melting points. They are also the poor electrical conductors, but they are the good insulators. As there is no any free electron is there, they cannot conduct electricity in solid form, remember. But in case of liquid form, they can conduct the electricity, because if there is a free mobile electrons, they can conduct the electricity. Then last part is metallic crystals, or these are also called as metallic solids. First important part is constituent particles. The constituent particles means these metallic crystals are made up with metallic bond. They are formed with atoms of the same metallic element. The first we have to understand what is meant by this metallic bond. In case of solid metal, the valence electrons means you know about this. So what is meant by valence electrons? These valence electrons are delocalized in the entire crystal, leaving behind the positively charged metal ions. So the metallic crystals are often described as sea of electrons. It is called as sea of mobile electrons. So the metals are good conductors of heat and electricity because of this mobile electrons. If the free mobile electrons are there, they can conduct the electricity. So metallic crystals having the properties of all the metals, they having malleable, then they can hammered into thin sheets, metals having the ductile, that is they can drawn into wires. All these properties of metals. So the metals, metallic solids having all the properties of metals, good conductors of heat and electricity, and examples are given. Metals like sodium metal, potassium, then calcium, lithium, iron, copper, gold, silver. So at a glance, we can remember all these characteristics one by one. See here, ionic crystals, characteristics, its properties are given. The constituent particles are charged ions. Then electrostatic force of attraction. These are hard, brittle, high melting point, non-conductor of electricity. Examples are given and the diagrams are given. Here also the covalent or network solids, the constituent particles are atoms. Then there is a covalent bond present. These are very hard, incompressible, having high melting point, poor conductor of electricity. Diamond cords. This is a diagram also shown. At a glance, we can remember the properties of ionic crystal also, covalent solid also, then molecular crystals. Again, this molecular crystal or molecular solid, it is having the three types, polar, non-polar, and hydrogen bonded. So the constituent particles are molecules here. The intermolecular, there are three types of intermolecular forces. First one is weak dispersion or London forces. It is, sorry, this is the printing mistake. Actually, the weak dipole-dipole interaction, the example should be HCl and SO2. And the CH4 and H2, these are the examples of dispersion or London forces. Then these are also soft, having the low melting points, poor conductivity of electricity. Means whatever the part we seen individually, it is kept in this table. So for the board examination, only just we can see this slide, and you can remember the all the characteristics. Examples are also given and diagrams are also shown. These are the London forces are shown in case of white phosphorus molecule. And we can, in case of this metallic crystals, we can see the sea of electrons. Sea of electrons means there are free electrons are there. All these properties of the metals can be shown by the metallic solids. So because of these free electrons, these are the good conductor of heat and electricity. Examples are given here: sodium, potassium, iron, aluminum. So for the examination purpose, we can read this one, or we can read this individual explanation is also given. And this is also, this table is also given. Means all these properties are also, this is included in one table. So this molecular solids, constituent particles are molecules, ionic solids, these are the ions, these are the dispersion forces. Means you can remember this slide also, you can remember this slide, or you can go through this chart. For the understanding purpose, I have again given this repeated slide here. One more slide is also given. This more slide is, all this slide contains the same material. This slide also contains the same material. This slide also contains the same material. So for understanding purpose, I have given this is 2 times or 3 times. Which slide you want easy, go through that slide. So tomorrow we will start this crystal structure. What is mean by crystal structure? Just I will give the introduction of the crystal structure, because only 1 minute is remaining. How the crystal structure is formed. Crystal structure, it is actually the ordered three-dimensional arrangement of particles. Crystal structure, it is nothing but it is ordered. Remember this, it is in proper order, three-dimensional arrangement of the particles. It can be explained by using the two terms. First one is lattice and second one is basis. So what is meant by lattice, I will explain first. The geometrical arrangement of the points in the three-dimensional periodic array. Periodic array means this structure is repeated. The geometrical arrangement of